Hello and welcome everyone. We've been tracking the Sean Prazard pattern problem, and this spreadsheet is linked in the description. So if you want to follow along, do check it out. Recently, I've started uploading codes in both Python and JavaScript in case that's helpful. And we'll be going through the code walkthrough of the next problem in the list. Basically, we want to find the smallest letter greater than the target. So that's a bit of a mouthful. So just go ahead and look at the sample. So we're giving this array of letters C, F, G, and we're giving a target of A. So the smallest letter that is greater than A is C. Now we can see that C is not in the array, but A, it's, well, just assuming, right? We can be given any of the letters within A to Z, and we want to find the smallest letter that is greater than the target that is present in this array. Now, obviously, the smallest letter greater than A is B, but we are choosing the smallest letter greater than target that is available to us in the array given. Now, that's important to note. Another thing to note is also that the letters is wrap around, meaning that it's kind of like a circle. So if we're given a target of Z, like I said, we can be given any targets from A to Z, right? And we're given a target of Z, but the letters are A, B. The wraparound means that we are going in a circle. We are going in a circle. Since Z is greater than all of these numbers, we're just going to start at the beginning. Basically, we're starting as if in a cycle, and that's going to be A, right? And lastly, the third thing to notice that, let me just bring back that, the last thing to notice is that this array is a sorted array in non-decreasing order, basically in ascending order. We have A, B, C, F, G. F is greater than C, J is greater than F. So basically, that is what we have. And there are other caveats that I chopped out while cropping this, and that is like all of the letters given are going to be lower cases. All right, so let's jump right into the code. Let's say that we're giving letters letters C, F, and J, right? And we want to find letter C. How do we go about this? So the straightforward thing to do is that we want to find C in the array given. We want to look for, okay, is C present in this array? And if C is present, then we can just look at the rightmost element to the target, right? Because since it's already sorted, then we know that whatever is at the right of C is going to be our target element, right? Now, how do we go about finding C? Let us assume that, okay, this is our array of numbers given, array of letters rather given. I want to find C. What is the most intuitive way to look for C? You can just think of a traverse. I will just loop through the array, find the index that this is, and return the element at this index. Let's say we find C at index 0, then we can just return the letter at index 1, and that is going to be the smallest letter that is also greater than C. But if you've watched the last video on binary search, you probably know that when we have something that is sorted and we want to find an element in an array, as long as it is sorted, the most effective or efficient way to search for a value in an array is using something called the binary search algorithm. And again, if you've not seen the video, it should be linked somewhere in this card. Do watch it. It's a way of searching for an item in an array in half the time. If you want to look for an item in an array, you're going to take O of n. It's easy to find C because C is the first letter in the array. But if we have to find something like J, that means we have to traverse the entire array. And that's going to take a whooping O of n time complexity. Now, this is not going to be efficient in the long run if our um array can grow as large as 26 characters, right? So how do we fix this? We use something called the binary search. The binary search just means, and this is just a quick rundown, more detailed walkthrough is in the example is in the question that we solved before, this binary search for beginners, right? So we just want to split up our array, and let me give us more room and just tackle this problem. So let's say we are giving an array of A, B, C, D, and E, right? And we want to find element E in this array. Instead of traversing the entire array, what we can do is that we can find the middle element. We can divide the array into two. And how do we divide an array into two? We just find the middle element. And in this case, the middle element is C. After finding C, we just check, okay, our target element is E. We check, is E greater than C? Yes, E is greater than C. And because E is greater than C, we disregard our leftmost element. Remember that we split our array into two by getting the middle. And so we just compare because the array is already sorted. And you know that we can compare values. The computer system, we can compare letters because the computer system is going to check their ASCII characters, right? So we know that, okay, C and E, we are comparing C and E, and we can say that E is definitely greater than C. So that basically tells us that we don't need to waste our time traversing the beginning of this array because basically they are lesser than E. We are never going to find E here. So we can focus our search on this portion. So that is what we are going to do that's what we're going to use to solve this problem, right? We are going to find, let's go back to our test case. We are given CFG. Let's say our target is C. We're going to divide this array into two by finding the middle, and the middle here is F. And then we can just check that, okay, is C less than F? C is less than F. So what do? We disregard the rightmost. We don't need this anymore. We're like, okay, we're done with you. And then we focus our search just on this. And while we focus our search just on this, we're going to continue our condition up until we have just two letters left or just two elements in the array left. And we know that once we are down to just two base cases, our rightmost element is going to be greater than the given element. Now we could have easily, you know, that when we used our number array, if you remember, when we have 1, 2, 3, 4, 5, we are stopping at once we find two, we are returning two. But in this case, we don't want to return two. We want to return the next elements greater than three. So we are going to return the rightmost elements greater than our target, which is going to be F. Now, how is this going to work if we have these cases that are more tricky, that are not in the target? Now, let me once again write out our given test case C, F, J, right? And let's say our first target is let me write them in a different shade so that it's clear. Our target is A, our next target is C, our next target is D, our next target is J. So let's say that we want to find the first item, which is A. Now, what are we going to do? We're just going to check if at any point this is going to be a base case. If A is less than the first item we are given, then definitely we know that the first item in our array is going to be our answer. If we have an element like C, that C is in the array, then we're going to run a binary search. If we're given an element like D that is not in the array, we are still going to run a binary search, and it's going to look like this. We have C, we have F, we have J. We want to find the middle element, like, right? We want to divide our array into two. And we're just going to check, okay, what is our middle element? Our middle element is F. And we're checking, okay, like, is F less or greater than D? And we can see that obviously F is greater than D. So we know that, okay, we do not need this side because it's definitely greater than D. We'll just assume that D is somewhere around this corner, and we're going to return our rightmost element. Now we can just move on back to our test case, that is J, right? And we can just check that, okay, is J the first element, is it less than the first element in our array? No, it is not. Is it the last element in our array? Yes, it is. And remember that this is a turnaround, is a cycle. So we're not going to return K, L, M, and all of those things. We're not going to bother with those. We're going to return the next element in the array, which is C. Now, this might be a bit confusing. It took me a minute to wrap around with all of the edge cases and turn around, but just try to draw it out, paint a picture of it in your mind. So let's say we're giving, this is one more, we're giving A, B, C, D, and F, right? So let's say we want to find E. Our first edge case is E less than A, because we know that it is possible that we are giving, let's assume that A is not part of this whole thing, right? It is possible that we're giving A as the target. And rather than running a binary search, which is a waste of time, we can just check, right? Is A less than the first element in the array? If it is, let just return the first element and no need to waste our time. Or is A equal to the last element in the array? If A happens to be F and we're not giving F, then we do not need to run a binary search. We just need to return again B, because we know that this is a wraparound. Finally, if it turns out that we're giving an element that it is not in this given array, we're going to run a binary search. Or if our element is in the array like a D, we'll still run a binary search and return the rightmost element. Let's jump right into the code. I feel like that might help you conceptualize it better. But if it helps, to go over all of this concept and try to come up with the code yourself before looking at the code walkthrough. All right, let's jump right into the code. And at this point, I'm going to ask that if you are not yet subscribed, please do subscribe to the channel. And if you like it, give it a thumbs up. If you do not like it, let me know what I might improve on. All right, let's jump right into the code. First, we want to define the upper and lower bounds. If we're giving C, F, J, we want to define, like, okay, at what point do we start? Because that's how we find the middle. We find the middle by getting the index of the first element, the index of the last element, and dividing it by 2. So let's first define those. So first, our lower and upper. Lower is going to be the first index, and upper is going to be the length of the array minus 1. And let's cover our base cases first. Just like we can see, if we have CFJ and we are given a target of A, let's say our target is A. A is not in the array and is definitely lesser than the first element. So we want to check that if target is less than the first item, right? Or, and just use lower since we already defined that. Or if target is greater or equal to the uppermost item. So this just means that if um if we have something like J, then we also want to return C. And if we have target that is A, we also want to return C. So we can go ahead and just return the first element in the array. But if either of these cases is not true, then we want to run a binary search that while lower is less than upper, let's define our middle. Let's get the middle first, which is going to be upper. Let's wrap this in a parenthesis. Upper plus lower divided by 2. This is going to give us our middle figure. And then we want to check that if the item at the middle is greater than our target, then we want to move our upper bound to the middle. And I'm just going to go right ahead and give myself some space here. Else that means that the letter at the middle is less than the target. It means that our scope is too high and we want to reduce no want to increase our lower bounds. Rather, in this case we are reducing our upper bounds. This just means that the element at the rightmost is too large and we want to bring it down. For instance, if we're giving D, for instance, and our middle number is F, this just shows that F is greater than the target, and so we want to move our scope to this side, to the left hand side, and just ignore everything for the right hand. Otherwise, we want to increase our scope. And this condition will run as long as our lower bound is less than our upper bound. And at the point where it can move no further, we want to return the rightmost element. And we're just going to run this, make sure that everything works fine. Oh, yeah, this should be commented out. Um, So it turns out that it's out of bounds because okay or target is greater or equal to not target upper. This should be letters upper because letters is the range. That's such a silly mistake. Yeah, sorry about that. Let's try to run this again. Right is not defined. Okay, sometimes when I define variables, I use upper, lower, left, and right to define two pointers. So let's be sure that nothing is going wrong again. We are defining our lower and upper bound. We're checking that our target is less than the letters or it's greater than the letters upper, and then we are returning the first item in the array. And while lower is less than upper, want to find the middle. If the middle letter is greater than the target, then want to reduce our upper bound to the middle. Otherwise, we know that the left hand is too small and want to increase our lower to the middle. And we want to return the rightmost element, which is going to be the upper bound. So let's run this again. And it all checks out. Let's submit it. And this works fine. By the way, the time complexity for this is going to be O of log n because we are doing this in half the time that we would normally use if we are traversing the entire element. We are not going from C, F, J. We're basically looking for the middle and then checking, okay, do we need the left scope? No, we don't. Let's flip to the next page, basically. And since we're not using any extra data structure or space, our time complexity is constant. So I'm switching this to JavaScript now. I'm just trying this out to see if this helps more people. So yeah, let's write this in JavaScript too. So first we're going to define our lower and upper bounds. This is going to be 0 or it's going to be letters dot length minus 1. And then we're also just going to write our condition if target is less than letters lower or target is greater than letters, not target again, letters upper, then we just want to return the first element in the array. And while our lower is less than our upper, we want to define our middle, which is going to be, we're going to have to do the math.floor, upper plus lower, then we're going to have to divide it by 2. And then we're just going to say that if letters, the middle letter is greater than the target, let's reduce our upper bound. Otherwise, we want to move our lower bound to the middle. And if all goes well and this runs, then we just want to return the rightmost element. That's going to be the smallest letter that is greater than the target. So that is upper letters, upper letters. And let's try to run this. This works fine. And if we submit it, okay, something is wrong. Okay, yes. Targets should be greater or equal to, because we can have CFJ and J is equal to J. So that should, let's try to run this again. So I just tried submitting, try to submit it, and yeah, this works fine. Same time complexity as what we had with the Python solution, log n time, and same space complexity, constant space. I hope this was helpful. Please let me know anything that you want me to improve on, anything that wasn't clear. I'll be glad to explain more. Thank you so much for watching, and I'll see you in the next video. Bye.